Hello, everybody. How are you doing? I know I'm between you and the break. I don't know if you just heard, but the team just added Jinja 2 template support for NSO. That's big. I know many of you asked for that, so thank you for the team. Now, the topic what I'm going to be talking about, it's a little bit different because I'm changing the persona. It's no longer the operator. It's no longer the developer. It's not the service developer. It's actually the operator that is basically doing the IT operation of NSO, correct? And particularly not just NSO, but any network automation tool. And this is very, very exciting. I did a talk like 4 years ago about how you monitor, how you manage. I think that's more and more important because one of the things that is happening is that the requirements are changing, correct? Because now we saw this morning with the Mass Orange presentation that actually the automation becomes critical for your success. That means that it has to be always on because now you have customer running network as a service. So actually you got an API and the customer is expecting that the changes are implemented fast, correct? And actually you may have many different clients. Some of them may connect via API, some of them may be operations, some of them may be just using the UI of your tools. So that change of requirements means that you need to rethink how you monitor, not just one tool, but the whole stack and the whole customer experience, correct? So in the past, and actually even today, I'm still receiving RFP from my customers who basically ask me, they still use, and you realize because of the font, now they're still using very old templates, correct, on how you monitor the manager, correct? And particularly looking at how we used to do it when you run EMS systems. These were typically, monolithic systems that actually basically provide you some statistics, and they were using traditional network protocols such as SNMP to connect to any other infrastructure. Now, the reality is that, of course, in the modern projects, we are not looking at one EMS isolated, running a UI, and me monitoring means basically going through the UI. We are running pretty complex set of tools, and even when we actually install one of our tools, let's call it CNC, inside CNC, you're going to have a lot of containers, a Kubernetes cluster. So the infra, even inside one of the given applications, could be pretty complex to monitor. So we need to change the way we are dealing with this. And one of the key things to understand is that we are not alone because the industry on application management in general has evolved. And particularly, there's a lot of work done in the last decades about application performance monitoring. So one of the key things about APM is that the basic idea has been to monitor not just creating dashboards, but looking at monitoring the customer experience and basically the business transactions. So there's an idea of business transaction, which probably it's very simple to us, and that's why we are associating as the first example to actually configuration transactions. But the business transactions are basically the changes your customers are doing. Imagine you are in a e-storm, correct? So you are buying in your web page. You basically select some products. Maybe you don't buy, okay? Maybe you cancel, or maybe you accept. So the idea of APM, it's also to provide a lot of data, a lot of traces to understand the behavior of the customer, to understand the experience of the customer, but also to profile it and to be able to understand what are they doing, what they're not, where they cancel, etc. Now, this industry is very large. There's a lot of big players, and actually Cisco acquired a company called AppDynamics a couple of years ago, and now we just acquired a company called Splunk, which has a product called the Splunk Observability Cloud, and both of them focus on this space. There are other companies in the world. Now, if I am Cisco, now I take the hat of an application developer, So I'm building, for example, an NSO, and I want to tap into this ecosystem. Until now, I had a big problem because each one of these applications had a different SDK. So you would say, simple, just instrument your application and export the data using AppDynamics APIs. You're Cisco. But the reality is that you may buy Cisco on Cisco with AppDynamics, or you may buy somebody else. So there is this dependency that was very hard to basically break. All right, so but that changed with Cloud Native. So when Cloud Native came on board, the industry got together, and there was a new standard called OpenTelemetry. OpenTelemetry is right now in the Cloud Native Foundation one of the most committed projects. It's where you see, together with something like Kubernetes, you see a lot of activity. So what's the goal? On one side is to break that dependency. So to have a protocol called OTLP that runs on top of gRPC or on top of HTTP, that runs on top of protobuffers and encoding, and that allow us to connect seamlessly with any backend. So your application creates data, creates telemetry that is exported to any backend. There's another thing that OpenTelemetry will do. It will give us also libraries, if you are a software developer, to a number of different environments and different development tools and languages. So basically, you have these bindings, but it's very simple now to implement instrumentation that then can be exported to any tool in the OpenTelemetry ecosystem, which today is basically any open source or commercial APM tool. Moreover, you see more and more, not just commercial tools exporting OpenTelemetry, but we see infrastructure exporting OpenTelemetry. I was talking to a customer today that I remember the first time we installed NSO, we needed to interact with some different agents that you needed to install to monitor CPU, power, etc. Or even when we were using, some of you may be using Prometheus and the instrumentation that tool brings. Right now with OpenTelemetry, yes, you can export to Prometheus, but you can also export to any other tool that you may be using. So there are special instrumentation for Linux, for Windows, but also for Docker, for Kubernetes, all of that available. Now, the important thing of OpenTelemetry is the word melt, M-E-L-T. What does it mean? M for metrics, E for event, L for logs, T for traces. So when we say what information do you export with OTLP, you're going to export melt, metrics, event, logs, and traces. All right? So that's very important because then, of course, the backend will be able to analyze all of this information. There's another fifth category, but it's not actually in the protocol, but it's about profiling. So remember that I told you about profiling and understand what kind of customers, what are they doing. So the idea of profiling and export this profiling from the application back to the backend. Now, you need to think about this OpenTelemetry as this lingua franca, but also as an innovation engine because of the amount of contributions that are there and the amount of support that you have from the different tools. It really makes integration extremely simple. Now, a lot of here are from the networking area. And probably you heard about telemetry in the context of networking, GNMI, OpenConfig, but maybe you never heard about OpenTelemetry, which comes more in the context of applications. So right now, these two are two different things. You're going to use OpenTelemetry to analyze applications, and you're using GNMI, Young Push, all of those, which I'm going to have a session on Thursday, to monitor a device and a router and the data that it provides you. Now, today, this has to be like this, even though, remember melt? Correct? There was the M. What was the M? Anybody remember the M? Metrics. And when you do a subscription to using gRPC, both of them use gRPC, for example. When you do a subscription to get telemetry from a router, what do you get? Metrics, events, correct? So semantically, it's the same thing, correct? But in reality, because we are using young models in the network, young model has a very deep schema, correct? However, the OpenTelemetry encoding is very flat. Anybody who has worked with telemetry knows that this is a problem also when we want to put the data we collect from the network into a time series database. Now, many times we need to flat what we get in because we're getting all that tree, correct? And we need to flat that in a way that we can put in the database. So right now, there are OpenTelemetry metrics for networking devices, but it's pretty much hand-coded for very specific metrics, correct? That you can get, oh, give me the interface statistics, give me the device CPU, but you cannot get the richness that you have with GNMI and getting the full young data models, okay? Now that's the status today, and as I said, OpenTelemetry is a big innovation engine. I cannot tell you what's going to happen tomorrow, but probably, you know, we will hear more and more about this OpenTelemetry standard. Now, there's a last point that is extremely important about OpenTelemetry. It also defines something called context. Why is context important? Remember that I told you that we wanted to map the intent of your customer, that business intent, that business transaction. We wanted to map that all the way until it gets to the device. So let's say you're running a NAS application, and you got a customer that is going maybe to ServiceNow, and you have a ServiceNow plugin for your operator. And through the ServiceNow plugin, they request a bandwidth upgrade, okay? So you have the plugin. You probably have an API gateway. You probably have some sort of backend. You probably have some sort of business logic in the middle doing some business check. Does it have money to pay for that upgrade, correct? And then finally, you get to the network automation. So how can I profile the experience of the customer all the way from the ServiceNow plugin to the network device? So what I need is basically that every component of that stack is actually exporting this OpenTelemetry data to the same backend. The second thing that I need is that when, let's say, the plugin sends the order, it actually sends something called context. And the context has basically two attributes that are very important. There has many, but let's forget about that a little bit. One is what we call trace ID, and the other one is the parent ID. Okay? Why trace ID is important? That is a global ID that every single interaction between systems connected to that original customer request will have the same ID. Okay? But the parent ID is also important because it's how I tell you that actually who's calling you, because I may do many calls. Let's take a normal NSO netconf commit. I may have a validate call. I may do a get call to check if something is available. I may do a post, okay? And if something went well, I may do a post check with another get. That's 3 calls. All of them are going to have the same trace ID, but each one of them we're going to have a different parent ID because the moment that was done in time was different, correct? So if we look at this picture, and it's very oriented to network and the reality of network. So we zoom in into the network. This is part of an IETF standard that we are pushing into the IETF, and that is to add this concept of context into netconf. We're doing the same thing for restconf. So because the W3C, which is the standardization body for HTTP, has standardized for normal REST. So what we are telling the IETF is, you know, any RESTconf client and server should support this new header. It's very important. But for netconf, we needed to add it into the standard. So this new netconf extension allows, let's call an orchestrator when it calls the controller, or even when it calls the device, and I'm doing a commit. Let's say you're doing your service commit on top, so you run your own application, maybe it's in Python, so you just send via RESTconf to your orchestrator that ID, those ID that I mentioned. So the orchestrator will sell to the controller an edit config with the trace ID 1, parent ID A. Now the controller will do certain things, will do validations, will do, inside will do something. But once it communicates with the network devices, to each one of them, it's going to send another edit config with trace ID 1, but parent now it's B, it's no longer A. And to the other device, it will be C, it will not be B, because it's in a different place in the process. Because everybody is now exporting these IDs to the backend can build the dependency graph, can really understand you did first this, then you did that, then you did that, and that's we're gonna see in the demo. Now, looks very, very generic, but think about NSO LSA. So let's call the orchestrator to be an NSO, and the controller to be a second NSO. So you are in an LSA mode, and you want to have traces, but you want to have that dependency on when the calls are done. All right? So in that environment, this netconf extension becomes critical. That's why we standardize it, because we need it for LSA tracing. So now in an LSA cluster, I can have all the traces and look at them with all the dependencies and everything in the right place. So we're going to be running, because LSA, remember, internally is running netconf. So this is extremely important. And that's going to be part of the demo. Now, this context addition was done in NSO 6.3. So the latest NSO 6.3, we're going to accept in netconf and restconf the full draft in the IETF that allows you to send all this context. Before that, we had a pre-standard, let's say, version that was not aligned with the standard, and the recommendation is to move to the standardized version. Now, let's look at the demo. So let's say I have an application. So my application has a client. And let's say this client is a mobile, or it's whatever a web client you may imagine. And the client, what it's going to do is to call a Flash-based, web server. Actually, Flask, sorry. Sorry for the typo. So I have a Flask web server. So what's going to happen is that, remember that I told you W3C, all the REST calls, correct? That can be done and send the trace IDs. So what I'm going to do is instrument my client, instrument my server, and every time I'm doing a REST call, I'm going to send this header, this REST header, that includes the trace ID and the trace parent. Now, the web server is going to do some work, and then what it's going to do is to call NSO. Okay? Now, when it calls NSO, in reality, it's going to use the same header, with the same format, same trace ID, different parent ID. And it's going to call NSO. Now, look what's inside NSO. NSO inside had already instrumentation. So you already have what we call progress tracing. So that's internal instrumentation that can be stored in CDB, can be pushed in a CSV file, but also in the latest releases, we created what we call Observability Exporter. So the Observability Exporter is going to subscribe to this. Instrumentation and expose it using OpenTelemetry, both for metrics and for traces. So right now, metrics and traces are supported. Which metrics? The same metrics you have in the counter format and what we call in NSO now Insight Manager, correct? Now, what I'm going to do from the top is two different services, L3 VPN and something called slow services. So I'm doing the two. Why? Because it's also a way with this profiling that you can check, for example, things like concurrency. You can check, we can demo that. We can demo commit queues, and you see in the application how things changes when you apply or not commit queues. Now, when I connect to the device, I'm going to use the net, and the trace and the context will not be exposed to the devices. Today, the devices don't support that, but because we are doing the standardization in netconf, that may happen in the future. What are the possible applications? Well, maybe you want to profile how the BGP process behave, how the OSPF process behave, those sort of things, and could also be exported. Now, each of these applications are going to send the respective metrics and traces to the OTLP collector. OTLP collector, yes, it supports OTLP, but also it's another innovation engine because it has drivers, basically adapters to Prometheus, but also to all different type of formats. So it can automatically do the translation between those different formats. The other thing that's interesting is that this application is running into Docker. And Docker is also instrumented. And that Docker is running into a Linux that is also instrumented. And all of that information, the same collector gets it over OTLP. And there's a lot of documentation online on how to make this happen, particularly in a Kubernetes environment, to make these traces and OpenTelemetry's environment working correctly. Most probably, your IT people have already a strategy for OpenTelemetry. Now, once you have the collector, what I've done in the demo, and I think this is something we showed you already last year, was that we can export to some open source tools. We can do Prometheus, Grafana, Jaeger. Each one of them either consumes the metrics or consumes the traces. But what's also interesting, and what I wanted to focus today in the demo, is that I can connect to commercial APM applications. What does these commercial APM applications bring to the table? So one of the things that they bring is that there's a lot of instrumentation already pre-built, okay? The other thing is that when they receive the traces, they also create a number of, they take the traces and they automatically create synthesized data. Synthesized performance data, but also ways to search the data in very different ways. And particularly they bring instrumentation for the most common deployment, Kubernetes clusters, Docker, etc. And they are probably very well advanced, as I said, into monitoring this business transaction, this idea of transaction profiling, and applying AIOps. That's why AIOps is one of the most common, when we talk about you search AIOps, many times the tools that you're going to be seeing are the tools that work in this domain. So that's the part that I wanted to do a short demo. And I'm a bit scared because of what happened, but I'm going to try to make it happen live. Wow, it worked. Yeah, OK. So I have two applications that I can show you. But the first thing I wanted to show you is the configuration of the OpenTelemetry. So from an NSO perspective, you basically have the progress traces, and you point the progress traces to the OpenTelemetry collector. That's the way you're going to do it typically, mainly because of security, because typically you're not running tracing applications, etc., just for NSO. Okay? So you got the keys of that you're going to be connecting, particularly if they are SaaS-based applications. All of that will be centralized on this collector. So you run you have a collector infrastructure. Again, depending if it is Kubernetes, where you put the collector, you may have a hierarchy of collector. All of that, your IT people are thinking about that. But you're going to be from an NSO, maybe in the same Kubernetes cluster, connecting to the collector, and from there to the backend application. Now, see here that in the same file, with the same collector, with the same data, we are connecting to different applications. What changes between the application a lot of time is the authentication. So you see AppD from Cisco requires OAuth 2, while Splunk Observability Cloud and LightStep, which now is part of ServiceNow, they just require a token. So if you use LogStep or you use Splunk, you just need a token. So that things change. But each one of them is going to have what they call endpoint, which is basically the URL that you send the data. And then what you do is you define these pipelines. So you say, hey, I take the traces that I received, and then on the output, I export it, and because each one of them has a different endpoint, you define different exporters. And here, I'm basically exporting to the different places and logging. You see that I'm exporting the traces and the metrics. Now, I'm using the same collector for my Python code and NSO. All right? Now, one of the things that I forgot to mention is from the perspective of monitoring, all of these tools were inserted with zero code. So remember what I told you about the innovation in OpenTelemetry? I've never seen something like that, that you have a protocol, a standard protocol, then 5 different tools integrate with zero code. And the reason a lot of that is because most of the vendors, including our Cisco NSO observability exporter, are using this SDK, which are distributed by the open source project. Okay? Now, you see here that in the case of Splunk, I have 2 things that I'm looking at. One is APM, and the other one is infrastructure. Now, APM would be the application in itself. Infrastructure is the Linux, the Docker, etc. But there's other areas that I'm not using, but it's another reason why you may be interested in these tools. One is synthetic traffic. I know I told you synthetic, you will think about Accidian. It's not Accidian. What synthetic means here is basically creating synthetic calls. So you can have a profile to say, you have a piece of your automation stack that, VPN creation, and you can create, delete, and basically profile that and create synthetic traffic, but in the application stack, not in the network. All right? So what I'm doing is, let's connect to the APM. So when I connect to the APM, the first thing you're going to see is that the tool automatically created all of this logic. So all of these dashboards were automatically created. And there's 2 ideas. There is services and business workflows. Now, there's no errors right now. That's why it was like that. But from a workflows perspective, remember that I told you that I have 2 services, L3 VPN and slow service. So it automatically understood what I'm doing. It automatically understood I have 2 services in NSO. I had not to do anything. And if I look at services, it automatically understood also that I have something called a web apps and a client app, etc. And if I click on it, there are a lot of instrumentation that were done automatically. Now, one of the main things is this service map. That was not possible before 6.3. Because before 6.3, we didn't have that arrow between ABC web app and NSO because we didn't have the context. The way the tool knows that there is these arrows is because we translate that, we transmit that context. Now you see there that there is this NSO FSO 8080. What's that? Well, in our implementation right now, we are not instrumenting the get calls. We're not instrumenting the reads. That means that, and in my test case, I am doing a read. So basically the tool is realizing you're doing a read, and I don't have anything sending me, there's no traces for this read. What do I do? But it can still do a profile of it. It can still know, because of the data on the server, it knows how much time it took. It just doesn't have traces, and it doesn't know that read is the same as NSO, but there you can program a little bit to actually make it fix. Okay? I just wanted to show you because it's intelligent, but there's also a little bit of limit. Now, of course, you have all of these success rate, etc. And as I said, you can also monitor the infrastructure. But what's very interesting for me, besides the infrastructure, is to show you in the APM side, you can take and look at the traces. So this is not very different from what we saw last year, but with one big detail. The tool is receiving the data and creating a lot of synthetic information. It's basically taking all the data that we sell them to sell the tool, and actually is creating metric for everything. And it's also creating queries and allow me to query from all the data that I have inside. So one of the data I get a lot from customer is, can I get a good profile on devices? Can I check, for example, how does a given device behaving, correct, in my network, particularly when you look at the transactionability of that device. And here I'm looking at that device, and I'm having failures just on purpose, and we're going to see where. But what's very interesting is that when you look at the services part, Is that NSO only? No. That's different also. Now, I'm profiling all the configs in a given device with all my stack, from the web app, from the mobile app, from the ServiceNow app, all the way to the device to understand, what's going on. If I click on one of these, traces, I should be pushed to my trace analysis tool. Okay? So this trace analysis tool, similar to what we saw before, but it's very much, it has two critical differences that we added recently. The main one is, you see there, the line where you have the web app put. What came after it? The NSO call. And you see that it goes straight behind the put. That is what I told you with remember the trace parent ID? Because the tool knows that everything is the same transaction. But it doesn't know only that. It knows that the put comes after the web app tool. So it knows exactly where it goes. In 6.3, we also added a new feature where if I take the commit transaction, I have the full diff set. So this is optional. When you when you configure this in NSO, you can configure it to actually send the full diff set, all the configs that were the diff set that were sent to services, but to the device also, all the way to the IAOps backend tool. This is extremely important because I learned with a tech engineer, friend of mine, who told me, Roque, when we got a tech ticket, 99% of the time, something changed. So something changed. It may change the systems, may change the environment. And from those, 90% of the time, it's a configuration change. So root cause analyzing configuration changes, taking your network information, but also having all the log of the configuration change all the way up to the application on the client in the same application, so you can actually do correlation. So now you know BGP is down, and you know which commit changed BGP, and you not only do know that, but you know which customer, if it's ServiceNow, or if it is from your operator, you can know all of that information. Now, this wouldn't be a 2024 call, presentation if we don't talk about AI. So one of the key things that we're going to do AI is with intelligent alerting, and of course SLO, so service level objectives, and the idea that you can do dynamic baselining, dynamic performance, and thresholding, and actually creating alerts. And from those alerts, you can even call for create some sort of closed loop into the application. So all of that, typically these tools will also give you that sort of environment and that sort of solutions. So if I click here in one of them, they were all defined. You're going to see the dynamic, where that dynamic situation happened. You see there that actually the rate of change changed. It was decreasing, then it started increasing. There's also root cause analysis, a lot of that into these APM tools. So I'm finishing here, just to give you, and I'm going to move then to my last, in my slides, I had some, sorry. So I just have some screenshots just in case something happened. So let me just move forward here. So we saw all of that. So just to conclude, there's a change in expectation that we know from network automation. Now it's becoming extremely critical, but also because we're exposing that to customers, it has to be always on. So performance is important, but monitoring, baselining, profiling, all of that becomes part of the equation. The other thing is that this can be seen as an opportunity to tie yourself to more of the, of the business outcome of your company, and actually also tap yourself into this very fast-moving AIOps, APM environment that actually is moving extremely fast. Now, of course, I think NSO is really at the head with, particularly in 6.3, with what we've done on supporting W3C. And my call for action is, I'm sure your IT team and somebody else in IT is actually thinking about this concept. It has probably decided already an APM tool. Of course, we hope it's one from Cisco, but it makes a lot of sense then you tap yourself into that in that move in your company. All right. So with that, I'm open for questions, and
All right, Marcus. Thank you very much, Roque. Very interesting. Just want to remind everybody to submit their questions in Slido so I can bring them up here. And in the meantime, while we're waiting for questions, great call out. Contact your IT teams. They probably have a strategy or a tool to ingest OpenTelemetry. So how do I know if my NSO supports OpenTelemetry if I'm not on 6.3 that you mentioned?
Yeah.
Maybe I'm on something slightly, older.
Yeah. So since quite a lot of time, we got progress tracing. All right. And then since 5.7, we introduced the OpenTelemetry collector. So what the OpenTelemetry collector is this way to automatically send the traffic to any OpenTelemetry collector and then system. So we got the OpenTelemetry exporter. You can go to the Cisco CCO and you download it just like you do with the resource manager. So no cost, no additional cost needed. What's very interesting is that even if you are previous to 5.7, I hope no, because probably you're end of support, that you can always do indirectly. You can export to comma separate CSV, and from there take the exporter and takes that CSV and can export via OpenTelemetry. It's true that you don't have all the features if you are not in the latest release. Again, metrics was added in 6.2, I think. And of course, this context was added in 6.3.
Okay, so we see additional capabilities
exactly.
as we move up the release.
But anybody can use it either directly since 5.7, or if you are in the previous version, you can use the CSV trick.
All right. I don't have any questions in Slido. Do we have any questions from the audience live? That's also possible. We have microphones down here that we can pass around.
I do have some surveys, I think, in Slido.
Survey.
Yes.
All right. Very good. There we go.
So how are you monitoring your NSO installation today? That's the question, correct? So you can go and vote, even if it is none. I think there was an option.
Maybe the... All right, we have one here.
Yeah, syslog is very common because, if you use something like Splunk, correct, syslog was the default mechanism to receive that information. Now, of course, syslog doesn't give you, actually in syslog, we can also expose traces in syslog, correct? That is also very interesting. All right. Can we move to, can we close it? Okay, let's move to the next one. Do you know what your IT team is using as an APM tool? Have you talked to them and you know what they're using? And again, there's also APM tools from the cloud players, so AWS, Google, Azure, all of them also gives you APM tools. Okay, very good insights. Thank you very much, and I hope you enjoyed it.
Thank you so much, Roque.